Imagine a machine that moves forever, cycling through a sequence of states but never actually consumes a single drop of energy to keep going. It sounds like a violation of the most fundamental laws of the universe, doesn't it? We've been taught since kindergarten that energy cannot be created from nothing. Yet here we are, staring at a phenomenon that seems to be cheating the system. Welcome to the strange, looping, and slightly impossible world of the time crystal. Before we dive into the how, we need to understand the what. In standard physics, we are used to crystals like diamonds or salt, where the atoms are arranged in a repeating pattern in space. But a time crystal is different. It's a state of matter characterized by the spontaneous breaking of time translation symmetry. This means that while the structure looks the same in space, it changes its state periodically in time, effectively creating a pattern that repeats through the fourth dimension. To truly grasp this, think about a looping GIF of a pendulum swinging. In our normal world, that pendulum would eventually slow down due to friction and gravity, eventually coming to a dead stop. But a time crystal is like a GIF that stays in motion forever, without any battery or external force pushing it. It doesn't break the law of conservation of energy because it isn't doing work in the traditional sense. It's simply existing in a state of perpetual rhythmic motion. This isn't just some sci-fi fever dream, though. The concept actually traces back to 2012, when the brilliant Nobel laureate Frank Wilczek first theorized the existence of these structures. He proposed that a system could exist in a state where its properties repeat in time, much like how a normal crystal repeats in space. For years, this remained a beautiful mathematical possibility, a theoretical ghost haunting the halls of quantum physics, waiting for technology to catch up. Fast forward to 2016, and the theoretical became the experimental. That was the year discrete time crystals were first observed in actual physics laboratories. Scientists moved from writing equations on chalkboards to actually seeing the rhythmic, non-equilibrium behavior in quantum systems. It was a landmark moment that proved Wilczek's intuition was correct, and it opened a door to a brand new way of thinking about the very fabric of time and matter. Now, you might be wondering, if these things are so small and quantum, how can we actually interact with them? For a long time, they were microscopic phenomena hidden within ultra-cold atomic chains. However, recent breakthroughs have changed the game entirely. Researchers have successfully used liquid crystals, the same kind of technology you find in your smartphone displays, to create visible time, crystal-like structures. We are moving from the invisible quantum realm to something we can actually observe. Let's take a moment to unpack the breaking the rules part, because it's a bit of a linguistic trick. When physicists say we are breaking symmetry, they don't mean we're smashing a glass. In physics, symmetry means that if you change something, like moving it or waiting a second, the laws stay the same. A time crystal breaks. This because its internal state changes even though the external environment remains constant. It's a subtle, beautiful violation of what we thought was a universal constant. Why does this matter for our future? It's not just about making cool, glowing shapes for science museums. The implications for quantum computing are massive, because time crystals are incredibly stable and resist being disturbed by their environment. They could serve as the perfect memory for quantum computers. Imagine a computer that doesn't lose its data because of heat or noise, but instead uses the rhythmic stability of a time crystal to hold information in a perpetual loop. Think about the current limitations of technology. Every device you own, your phone, your laptop, your car, is fighting a constant battle against entropy. Entropy is the universe's tendency toward disorder and heat. Everything eventually slows down, cools off, and dies. But the time crystal exists in a strange loophole. It operates in a way that bypasses the typical pathways of thermal decay, offering us a glimpse into a world where motion and time are decoupled from the standard cost of energy. Of course, we need to manage our expectations here. Before you start trying to build a perpetual motion machine for your garage, let me be clear. A time crystal will not power your house. It doesn't produce extra energy that we can harvest to plug in a toaster. It is a state of matter that moves without consuming energy. But it doesn't act as an infinite fuel source. It's a fundamental shift in how matter behaves, not a magic wand for the energy crisis. So, what is the deep dive takeaway here? We are living in an era where the lines between impossible and observable are blurring every single day. The discovery of time crystals tells us that our understanding of thermodynamics and time is still incomplete. It suggests that there are hidden rhythms in the universe, structures that don't care about the arrow of time or the drain of entropy. We are learning to dance to a new beat. As we continue to refine our ability to manipulate these synthetic quantum systems, we might find even stranger states of matter waiting in the shadows. Perhaps the next breakthrough won't just be about seeing time crystals, but about using them to navigate the very dimensions we once thought were untouchable. The universe is much weirder than we give it credit for, and we're just beginning to scratch the surface. If you found this journey into the quantum realm as mind-bending as we did, make sure to hit that subscribe button. Here at SciNova, we're constantly chasing the edge of what's known and what's possible. Join our community of curious minds, and don't forget to ring the bell so you never miss a leap into the unknown. Thanks for watching, and we'll see you in the next dimension.